Hey, welcome to 16-Bit Bench. Matt here. We're revisiting the Master System 2. In my previous video, I showed you how to fix a fault with the RGB DIN connector on the back. And in this one, we're going to 50-60 Hertz mod it with a switch, and we're going to put in a little power LED as well inside the power button. So they're two relatively simple mods. That's why I'm doing them in one video. The 50-60 Hertz switch just involves connecting a switch to one of the pins on the video encoding chip, and the power LED just involves putting a LED inside there and then wiring it up. So yeah, let's crack open the Master System and have a look at what we need to do. Right, so that's the board stripped down. This is one that I've already done a repair of the DIN connector on. It's not the same as the one from the video. This is the one where I replaced the DIN connector entirely because the old one was cracked, and ran a cable tie around it to replace the metal strap. It also involved drilling a couple of holes in the board and taking a Dremel to the front there so you could actually get the ground pins in at the front because they didn't match. But all the back pins here did match. Yeah, so this has blue wires on it. The one we did in the video has orange, but other than that, it's pretty much the same. So what we need to do for the 50-60 Hertz mod is lift one of the pins on this chip. I think it's pin 57, but we'll confirm that in a second. And then that pin either needs to be at 0 or 5 volts, depending on which frequency you're going to be using. And then we will be probably hooking an LED up to the power switch. So when it's power switch is on, an LED comes on, and when it's off, it's off. So one of the things we're going to need to think about is where we position the switch in the case. So it's that way. When the board is in the case, like that, you can see we have this whole empty area over to the right side as I look at it, this side. So this would be the perfect area to put any switches and run any wires. It gives us a load of space. And for the 50-60 Hertz mod, we're going to this chip here, so it's not that far away. And because we're dealing with voltages, we're not dealing with signals, it doesn't really, if it was a very fast clock pulse or something, you may want to be closer to where you are, but with this we're just going high and low, so like just flicking a switch over here. Yeah, so I'm going to there's a nice little shelf here along this edge. So I think that's perfect for the switch to sit on top of, and I'll be able to glue it in that position. So I've got these tiny little sort of switches that I'm using, dual pole, single throw. That's what it is. Yeah, so I'm gonna glue that little guy there. I'm gonna Dremel out a hole, and he'll just pop out on the side there. I think that will work quite well. Yeah, so for the LED, it's going to come up through the power switch. So the power switch sits on top of that switch there. So I'm going to put an LED inside the switch, and then run some cables out the side for it. So we're going to have to drill a little hole in the side there, and then the cables will come out the side. Yeah, and it'll be just there. So that's pretty cool. So we're going to put the LED inside the power switch. It's about a 5mm hole in here, but there's two standoffs either side, and they're required in order for it to grab the power switch. If they're not there, then turning it on and off is going to be harder. So we can't remove those and put a 5mm LED in. We have to put a 3mm LED. So I dug around in my box of crap, and I found a red LED in there. And I think it's quite a low power LED, because when I tested one without a resistor, it killed it straight away. So this one let's just power it to 5 volts. There we are. So you should just be able to see that there. Can we see that nice and red? Yeah, we can. So that's the LED powered to 5 volts. It's bright enough for a power LED. One thing I really hate is really bright LEDs on things, because if you're in your bedroom or whatever, or if they're on a handheld, like the Game Boy DMG1, that LED is annoying as hell because you're staring at it all the time. It's right there. Anyway, so I had to put a resistor in line with it, and this goes back to my old A-level electronics. So it's V equals I R. In this case, V is 5 volts. I hope I'm getting really good at writing upside down. R in this case is 75 ohms. So we don't know what I is. So we rearranged the formula. So it's 5 over 75. That's weird, isn't it? I got that backwards. Equals, so 5 divided by 75 is, I could do it in my head, but I'm old and I don't want to. 75 divided by 75 equals 0.0667, which is 66 milliamps. Which is quite a low current, and seems this LED is quite happy. It's not hot, so yeah, that's a good voltage, a good resistor value to use. 75 ohms in this case. I think most LEDs we used to just chuck 270 ohm resistors in line with our LEDs. So that used to work fine, but obviously that would be a much lower current than this one. I used a 270 ohm when testing this, and it was very, very dull at 5 volts. So then I tried a 100 ohm resistor and it was still pretty dull, and then I tried 75 and I'm quite happy with the 75, so that's what we're going to use. In order to install it, we need to drill a hole in the side of the switch so the wires can come in and out, and then we need to take a Dremel to the slot in the switch and just Dremel out some of that hole. Okay, so I've drilled the switch. Let's just take a look on the iPhone. So the two things I've done is made a hole in the side of the shaft there, and then I've drilled out a bit at the top, and the LED will sit down in that hole. You can just see there, it's my finger, and it will glow out from there. What I might do is put some tape over this, and then maybe put some hot glue in there to make a little light pipe. See if we need that. I'll think about doing that. Yeah, if you were going to do that, you could probably use some clear acrylic or something like that, but I don't know if it's going to work, so I want something that I can remove easily, and hot glue will just peel right off. So yeah, looking pretty good. I'm very happy with the position of that switch, where the LED sits in there now. So what I'll do in a minute is just glue that in place and leave the legs out like that, and then we can solder the resistor in line to the positive leg, and yeah, that'll be the LED in position. So while I've got the Dremel out and there's bits of plastic everywhere, we might as well look at the case as well. So like I said, I wanted to position the switch on this little shelf inside, probably right on the edge of it there. So what we're going to need to do is drill a little slot there for the switch to poke out through. Right, so I've fitted a hole in the case. If I'm completely honest, let's take a look here. That is not as neat as I would have liked. Yeah, it's the problem with trying to cut a hole, a perfectly square hole in this, like right in the middle of the side of something. It's not massively easy. Yeah, and I slipped with the Dremel on the top there. That's why it kind of bows out, which is a shame. So what I could do is maybe glue some kind of cover over it or something. I have to think about that. Okay, so yeah, now we've got a hole for the switch, and I need to secure the switch in position, and then I need to think about putting it all together. I've been struggling a bit with the switch on the side here. I've decided not to go with a little micro switch. I'm going with this bigger switch that I've found. Reason for that is twofold. One, this looks much nicer on this hole on the side, because it has a surround on it. It just covers up any of the kind of wobbliness in the hole. You can still see a little bit, but it's much better than the little switch. And the second reason is it's just a bigger switch. It's easier to flick. So yeah, that makes the mod easier to use, really. So yeah, we're gonna go with this switch on the side like this, and I'm gonna glue that in, and yeah, then we'll get to the electronics part of this. Okay, so I've positioned the switch and I've glued it in there, and I've positioned the LED in the power switch and glued that in as well. What we're going to do now is run the wires for everything. So for the switch, I need 3 wires, and they're going to be going to the sort of chip here, the 315 chip. So the middle wire is going to go to pin 57, and we need to lift pin 57 from the board, or we could just snip it and lift it, or whatever. I think I'll try and heat it and lift it. And then the other 2 are going to power and ground, so we're going to do that. And then above the power switch, we're going to be running cables from the LED to the power switch, so when the switch is engaged, the LED glows. So that's the other step to do. So I've lifted pin 57. Let's just take a look. Here we are. You see it's disconnected from the board there. So what I'm going to use is a little bit of this heat shrink to cover the pin and the connection. Then I can just press it back to the board, and yeah, we'll be good. Yeah, I'm 100% confident now that this is the 5-volt rail. So I've got continuity from this point to the output of the primary voltage regulator, and then I've got continuity also from this point to one of the pins on here, this one, and then I've also got continuity to pin 1 on this chip here. So yeah, that is the 5-volt line, continuity between there and the output of the voltage encoder as well. So that indicates this is 5 volts. We got 5 volts over here, and we got 5 volts down there. This one, you can see that is ground because it's connected directly to the ground plane, which is here, the orange copper that runs around the whole board. It comes straight down to here. So yeah, these are our power and ground points. As you can see, I've wired it through the shield, which I think I've done the wrong way around, so I have to resolder that. But yeah, the idea was to have it come through the shield and come out here, and I've done that upside down, so I'll fix that now. But yeah, now we can test the board to see if it's switching between 50 and 60 hertz. So I just flip around real quick, and I'm going to use the iPhone for videoing the difference between the 50 and 60 hertz. So this is Alex Kidd, that's the built-in game, and that is running at 50 hertz. Take a note of the screen, it's squished, and the music, and the tempo of the music. Okay, so we can throw the switch while the console is powered on. Okay, now the machine's running at 60 hertz, the screen is bigger, and the music is faster, because it's actually running at the intended speed. Still, it's really good. Like there's no problem with it. Yeah, it's really interesting actually. Like I've got so used to the Alex Kidd music in the old slow 50 Hertz way instead of the 60 Hertz way. Great, so that proves the switch is working, and the work we've done is good there. The next step is to put the power LED in and check that works. The 50-60 Hertz switch is tested and working and works really well, so I'm really pleased with that. The last part of the mod we're going to do today is put a power LED in. So when the power's on, there'll be an LED shining through here. So what this power switch actually controls is power flow directly to the voltage regulator. So what we can do is we can solder an LED across common and output of the voltage regulator direct from here and run a cable along and sort of in the corner. And then what I need to do on the LED is I need to put a resistor in line, this resistor here, in line with the pins, and then I'll just cover that whole thing with heat shrink. Okay, so that's the two mods positioned. Got the 50-60 Hertz switch over here, and then our LED here. So if I just plug the console in on the bench, turn it on, there you go, there's the LED on. Off, on, off, on, off, great. And yeah, so all that remains now is to put the console back together and then wire it up and play some games on it. So let's get on. Hey guys, so here we are. This is the Ultimate Master System. Forgive the noise in the background, I'm just messing around with a 3D printer. So the Ultimate Master System has a power light, you can see on the on-off switch. Has a 50-60 Hertz switch, so you can see the size of the screen kind of increases almost by a third when it's in 60 Hertz mode. Here you can tell especially, look at that. So in 60 Hertz also the gameplay is slightly faster. And then this is was an RGB Master System, so it already has RGB out, that's what we're seeing. So this is the best picture at the best frame rate you can pretty much get on this console. So for a Master System 2, I think this is pretty much the ultimate mods that you can have. So yeah, I'm really pleased with this. It was a couple of simple mods plus the RGB fix that we'd already done a few weeks ago. Yeah, so if you liked the video and you found it useful, please like and subscribe on YouTube. Follow us on Facebook and Twitter, 16-Bit Bench. We're doing all kinds of videos and all kinds of fun stuff, and like now I've got a 3D printer and I'm going to print spare parts for controllers and replace all the D-pads that are missing on these Master System pads. And coming up in the future we'll be doing mods on Super Nintendos and Mega Drives, and I've got some CDIs, N64s, Intellivisions, these French Ataris, which only have 16 colours but look super cool. We'll be doing all that kind of stuff, so please, if you want to watch that stuff, subscribe. And I'll see you next time. Thanks a lot, and goodbye.